Hi guys, so ngayon naman pag-uusapan natin yung topic about Newton's divided difference interpolation. So we have objectives for this topic. First one is to derive Newton's divided difference method of interpolation. Next is apply Newton's divided difference method of interpolation. And third, apply Newton's divided difference method interpolants to find derivatives and integrals. So, yung definition ni Newton's divided difference interpolation is used when there is an equal gap between each term of x. Kasi may iba't ibang klase tayo ng interpolation, but for specific Newton divided difference method, we are using this to solve those problem that has an unequal gap between each term of x. For example, this table, we have on the term of x 2, 3, and their gap between each other is 1. Next is this 3 minus 6, or yung gap nila from each other is 3. 6 and 7, gap nila is 1. And 7 is 9, gap nila is 2. So, makikita mo agad na ang laki ng gap nila from each other. Hindi siya sunod-sunod. Kaya, para malaman natin yung specific term na kailangan nating mahanap, pwede natin gamitin yung Newton's divided difference. Okay, so let's start by deriving the linear interpolation given x sub 0, y sub 0, and x sub 1, y sub 1. Fit a linear interpolant through the data. Chosen yung x sub 0, y sub 0, and x sub 1, y sub 1. Kasi pag given tayo ng pag given tayo ng maraming points, pero pag gagawin natin tong linear interpolation, kailangan natin is 2 points, and ganito talaga sa linear interpolation. Sa mga example ko, mapapakita kung paano pumili ng points, but for now, focus muna tayo sa derivation. Ayun nga, given tayo ng mga points na to, x sub 0, y sub 0, x sub 1, y sub 1. So basically, given din tayo ng y is equals to f of x, and y is a function of x, and given lang din tayo ng terms of y ng x sub 0, x sub 1, so we can call this a discrete function. Many times sa solving nakikita nyo na gagamitin natin tong magagamit natin tong interchangeable na y sub 0 to f of x sub 0, or yung y sub 1 sa f of x sub 0, x sub 1, I'm sorry. Kasi given tayo ng y is equals to f of x, we are given a function of x, y as a function of x, and that function is given at, let's say, a certain number of data points. So, etong yung dalawa, ay interchangeable yan. Kaya kahit paliktarin mo yan, pwede mo silang gamitin. Kasi may mga example na y yung gagamitin, yung ibang example f of x sub 0, f of x sub 1 yung gagamitin. Let's compare naman pag gumamit tayo ng direct method, and pinili natin tong linear interpolant to be y is equals to a sub 0 plus a sub 1 of x. Sa ganitong scenario, meron kang dalawang coefficients, which is a sub 0 and a sub 1. And this will be your linear interpolant, which we need to find at magsiset up tayo ng two equations, two unknowns, by basically saying that this is particular value of at x is equals to x sub 0, the value is y sub 0. So ito ang kakalabasan yan. X sub 0, y sub 1 plus a sub 0 plus a sub 1, x sub 1. Kasi nga, diba, sinabi ko kanina na this particular value at x is equals to x sub 0, the value is y sub 0 din. So, ayan yung sa direct method. Ayan yung nag-set up ka ng dalawang equations, dalawang unknowns, solved for a sub 0 and sa a sub 1, and it will be your linear interpolant. Yan yung sa direct method. Pero dito sa Newton's divided difference polynomial, gagamit tayo ng first order polynomial, pero magagamit yan with a different form. Yung different form is f sub 1 of x, which is this stands for the first order polynomial, is equals to b sub 0 plus b sub 1 x minus x sub 0. So, pumili lang tayo ng form na still a linear interpolant, ito, but the form is chosen to be b sub 0 plus b sub 1 times x minus x sub 0. We still have the two unknowns, ito, ang dalawa. And the reason why pinakita ko yung comparison nitong direct method, yung direct method na to, sa NDDP is because for us to appreciate the Newton divided difference polynomial, although it will give or it will still give the same polynomial kahit pareho mong gamitin yung method na direct at saka NDDP or any other method. Magtataka kayo bakit ginagamit pa to or mas convenient to sa ganitong mode or method na iba-iba yung gap ng terms of x, tas ito yung gagamitin imbes na direct method. I-explain ko pa din yun. So let's start on finding b sub 0 and b sub 1. Alam natin na ang value of the function at x sub 0 is the same as the function, wait lang, x sub 0, para mas malinaw, since at x equals to x sub 0, ito yung sinasabi ko. So, f of x sub 0, the same pa din siya. This is the same as the function at x sub 0, which is same as y sub 0, and will be equal to b sub 0 plus b sub 1. X sub 0, kasi nga papalitan natin, di ba x yan? Papalitan natin x sub 0 yan. Minus x sub 0. Sinubstitute ko lang yung value ng x is equals to x sub 0 dito. So, we will get, since this will be cancelled, 0, f of x sub 0 will be equal to b sub 0. Kasi this b sub 1, x0 minus x0, will be equal to 0 na. So, cancel na sila. Same thing dun din sa isa, na alam natin na itong first order polynomial which we have at x sub 1, since at x equals to x sub 1, ganun din, f sub 1 of x sub 1 equals to f of x sub 1. Ito will still be equal to the value of the function at x sub 1, which is again the same as the value of y sub 1 will be equal to b sub 0 plus b sub 1 x sub 1 minus x sub 0. And alam din natin na ito is f of x, since alam natin na b sub 0 is f of x sub 0. Ito, di ba nakuha na natin to, equal silang dalawa. So, pwede mo yung palitan na f of x sub 0. By the way, kung nalilito kayo, hinahanap na natin yung para sa b sub 1 kasi meron na tayong b sub 0 na formula. So, we can just substitute yung f of x sub 0 kasi meron na tayong value of b sub 0 eh. Kaya ilalagay na lang natin siya. F of x sub 1 is equals to f of x sub 0 plus b sub 1 x minus x sub 0. So, ayan na yun. Na-substitute na natin. So, pwede na natin makuha yung b sub 1 dyan na formula. Para mas malinaw, iisa-isahin natin. Derive, lalabas mo lang to f of x sub 1 minus f of x sub 0. Pag labas mo dyan, b sub 1, x sub 1 minus x sub 0. Divide both sides by x sub 1, 0. X sub 1, x sub 0. So, therefore, ito na yung yung b sub 1 natin. Ito. Rewrite ko na lang lahat ng, so, therefore, we already accumulated the formulas for b sub 0, f of x sub 0, and b sub 1 is equals to f of x sub 1 minus f of x sub 0 over x sub 1, x sub 0. Kaya na nating makuha si b sub 1 by simply subtracting the values of the function at 2 points that was given, ito yon, divided by the difference between the two x values that was given on a specific given or example na kahit anong ma-solve or problem. Ganun. So, ang pinakaiba lang nito sa direct method, again, is that yung values of the unknown coefficients, b sub 0 and b sub 1, ito, which is hinahanap natin dito, nakuha natin yan without having us to solve equations, two simultaneous linear equations. Nagsosolve pa din tayo ng two equations, pero they don't have to be solved simultaneously compared sa direct method. So, ayun yung sinasabi ko earlier na convenience nitong Newton's divided difference interpolation method, that the coefficients of the polynomial are obtained by just solving one equation at a time, compared to direct method where we have to solve two simultaneous linear equations. So, balik tayo dito. Based on what we have right now, ito ang ating NDDP, Newton's divided difference polynomial. Dinerive para makuha tong dalawa na kailangan para ma-fill up yung kulang dito na points. The first order polynomial which we have used earlier to approximate our function from x sub 0 plus x sub 1 is given by this, where b sub 0 is the value of the function at x sub 0 and b sub 1 is the value of the function. This is a slope where the slope between x sub 1 and x sub 0, and a straight line slope between 2 points, and is given by this. Ayun, we have given by the value of the function at the first point, ito yung first point, and the value of the slope between the first derivative slope between x sub 0 and y sub 0, ito. So this one is written also as f of x sub 0, and it is also called as the zeroth divided difference. While for the b sub 1, it will be, kita pa ba akin? F x sub 1, x sub 0, and this is called the first divided difference. Tinawag natin silang divided difference method, itong tag-isa method. method dahil sa gumamit tayo ng divided difference approximations for the slope and for the function itself. Hindi pa natin ma-appreciate yan sa ngayon, pero pag natakal na yung sa second order interpolation and general order interpolation, makikita nyo yung importance or yung significance of rewriting these unknown coefficients, itong b sub 0, b sub 1, to these particular forms. Ito. So, yun lang. Yun na yung Newton's divided difference interpolation. Sana na-gets nyo naman. And, I will discuss yung algorithm. Ayun na. So, ang algorithm kasi, or yung steps, steps natin, para mas magets nyo ng mabuti bago tayo mag-proceed sa examples. Una, choose 2 points. Sa madami kasing given sa linear na mga problem na kailangan mong pumili ng 2 points, don't worry, i-indicate naman yun sa problem. And depende rin yun sa problem. Basta unang step doon, pipili kayo ng 2 points na magsisilbing x sub 0 nyo at y sub 0. Next, prepare the formulas and givens. So, yun nga. Ang formula natin, itong first order formula na f sub 1 of x equals to b sub 0 plus b sub 1, x minus x sub 0. B sub 0 is equals to f of x sub 0, b sub 1, f of x sub 1 minus f of x sub 0 over x sub 1 minus f sub 0. Yung mga formula yung tandaan nyo. Third, solve for the b sub 0 and b sub 1, of course, kapag hindi given. Depende pa din sa problem. Pero ito yung talagang step. Number 4 is substitute all the answers and givens to f sub 1 of x is equals to b sub 0 plus b sub 1 x minus x sub 0. Ikukunin mo na lahat ng kuha mo answer mo dito, substitute mo na lang dito. Then solve for the final answer. Ayun, so para mas maintindihan natin nga mag-examples na tayo, and see you.